Hello, my name is Mr. Asprey and this is MadAsMaths MP2 Practice Paper A. These papers are really challenging and I'll just explain quickly what the coding means. On its website there are MP1 papers which closely follow AS level EDEXCEL, and there are MP2 papers like this one which closely follow A level in full EDEXCEL, and there's also synoptic papers as well which are slightly harder than MP2 and they don't really follow a particular exam board. They're suitable for all exam boards. So this paper is great if you're doing EDEXCEL, but it's also really good if you're doing other exam boards as well, because it's just high level A-star type A-level maths pure questions. If you do find it useful, please do subscribe to my channel. I'm trying to get to 1,000 subscribers within 100 days and I've only got 2 days left. So please do subscribe and like and share the video if you find it helpful and useful. Okay, let's get into it. Vectors. We have a coordinate A and we know what A to B is. And we need to work out the coordinate B. So the fundamental rule of vectors is that A to B is equal to OB minus OA. So if I'm trying to find OB, I would add OA to both sides. And that'll give me OB. So I just need to add these two together. A to B is 3 minus 1, 5. And O to A is the position vector of A, so thus it's just the coordinate of A written as a column. Add these together, give us 5, 0, and 2. So the distance is the magnitude of the position vector, which is the square root of 5 squared plus 0 squared plus 2 squared, which is the square root of 29. Vectors. We have a coordinate A and we know what A to B is, and we need to work out the coordinate B. So the fundamental rule of vectors is that A to B is equal to OB minus OA. So if I'm trying to find OB, I would add OA to both sides. And that'll give me OB. So I just need to add these two together. A to B is 3 minus 1, 5. And O to A is the position vector of A, so thus it's just the coordinate of A written as a column. Add these together, give us 5, 0, and 2. So the distance is the magnitude of the position vector, which is the square root of 5 squared plus 0 squared plus 2 squared, which is the square root of 29. We have a small angle approximation and we need to know that sine theta is approximately theta when theta is small, and in radians, and cos theta is 1 minus theta squared over 2. These are given in our formula booklets, so we don't need to memorize them. Here we have the cos of 7x, so if I'm using this small approximation, then I would say that theta is equal to 7x. So that's going to give me 1 minus 7x all squared over 2, and then minus 1, and then all over x, and then sine of x would just be x as well. So we're going to get a positive 1 and a negative 1 on top like that, so they will cancel. And this is going to be minus 49x squared. And that's over 2, so that can come down to the bottom line. And then we've got x times x is x squared. So great, this is going to cancel these x squareds, and we're going to be left with minus 49 over 2. Okay, next question. We've got the sum to infinity of a geometric sequence is 3 times larger than the first term. So the sum to infinity given in your formula booklet is this. And it's 3 times bigger than the first term a, which means if I multiply a by 3, then they are going to be equal to each other. Okay, we can divide through by a here. And then we can multiply up by 1 minus r, which gives us 1 is equal to 3 lots of 1 minus r. Expanding out, or sorry, dividing by 3 gives me a third is equal to 1 minus r. So that means that r must equal to 2/3. Okay, now let's look at the next bit of information. The third term of the same series is 40. Well, the nth term of a geometric series is ar to the n minus 1. So the third term is ar to the 3 minus 1, which is 2. And we know that's equal to 40. And we know that r is equal to 2/3. So we can do, on our calculator, 40 divided by 2/3 squared, and we get 90. So a is equal to 90. Okay, great. That looks like part A is done. Part B, determine the exact value of the sum of the first 4 terms. Well, the sum is always equal to the first term, 1 minus r to the n, which in this case is 4, all over 1 minus r. So subbing in what we know, we have 90, 1 minus 2/3 to the power 4 over 1 minus 2/3. Okay, so that can go into our calculator. Okay, so putting that into our calculator gave me this. So therefore, S of 4 is equal to 650 over 3. We have proof by contradiction. And we start proof by contradictions by assuming the opposite. So we say assume cos theta plus sine theta is greater than root 2. And I'm going to square both sides to give me this. Squaring out this bracket is going to give me a cos squared plus a cos sine plus another cos sine plus sine squared. We know that a cos squared plus a sine squared is equal to 1. And right here we have 2 lots of cos theta sine theta, which is greater than 2. And we know that 2 cos theta sine theta is the same as sine 2 theta. Subtract 1 from both sides gives me this. And this is a contradiction. And this is a contradiction because we know that sine 2 theta has to be between -1 and 1. And then we can write therefore the original statement is false, and the negation of that is true, and we've proved it. QED. Great. Question 5, we have a circle, we have a tangent, and we have a radius, and we have a line going here, and we are told that the arc length in here is 2 pi. So that line there is 2 pi. And we need to basically work out the shaded region. Okay, So I know that the arc length L is equal to the radius times theta. It's one of our formulas that were given. Not given in the exam actually, sorry. So we can work backwards to find what theta is, because the arc length here is 2 pi and r is 6. So therefore theta is equal to 2 pi over 6, which is pi over 3. The area formula for a sector is half r squared theta. So in this case, this is a half times by 6 squared times by theta, which is pi over 3. This gives us 36 divided by 2 is 18, divided by 3 is 6. So this just gives us 6 pi is the area. Okay, so this is the area of the sector, is 6 pi. The blue area there. So next I'm going to try and work out the area of this triangle that looks like this. We know that angle is pi over 3. We know the radius up there is 6. So let's try and find this value here, x, or PR should I call it. Okay, so we're just going to use SOHCAHTOA for this. So we know that tan of pi over 3 is equal to the opposite PR over the adjacent 6. So PR is equal to tan of pi over 3 multiplied by 6. And tan of pi over 3 is a root 3. So root 3 times 6 is just 6 root 3. So the area of the triangle will be a half base times by height, and this will give us 36 divided by 2, so 18 root 3. Okay, so finally we can work out the shaded area by doing the triangle, which is 18 root 3, minus the sector, which is 6 pi. We can factor out 6 to get 3 root 3 minus pi. And that is as required. Question 6, a tricky implicit relationship. We need to work out the gradient at a particular point. So I would recommend multiplying through by x plus 1, y plus 1 to get rid of the fractions and avoid using the quotient rule. So when I multiply through, I get x lots of y plus 1 plus y lots of x plus 1 is equal to x squared x plus 1 y plus 1. Expanding the brackets gives me xy plus x plus another xy plus y is equal to x squared, and I'm going to get xy plus x plus y plus 1. Simplifying further, this is going to have 2xy on this side plus x plus y, and multiplying out these brackets is going to give me x cubed y plus, we have x cubed plus x squared y plus x squared. And now we need to differentiate, bearing in mind that we're going to have these three products, so I have to use the product rule for those ones. Now when using the product rule, I will differentiate split them into halves like these. So differentiate the left side, which is going to give me 2, and then keep the right side the same, and then keep the right side the same and differentiate the left side. Differentiating x gives me 1, differentiating y gives me dy by dx. Okay, so we're going to differentiate the left side, which is going to give me 3x squared, keep the right side the same, and then we're going to keep the left side the same and differentiate the right side. Differentiating x cubed gives me 3x squared, And again, another product here, so we're going to differentiate the left side, keep the right side the same, then keep the left side the same, and differentiate the right side. And we are also going to get 2x at the end. Okay, we could collect up all the dy by dx's, factorise, divide, get an expression for dy by dx, but that's just going to take extra time. We don't need to do that. Let's just sub in 1 and 1. So when I sub in 1 and 1, I'm going to get 2 here plus 2 dy by dx plus 1 plus a dy by dx. And we're going to get, this will be 3, this will be dy by dx, this will be 3, and this will be 2, and this will be a dy by dx, and this will be plus 2. Okay, great. Let's see if we can do some simplifying just to save us some time. A 2 and a 1 can cancel with a 3. A 2 dy by dx can cancel with 2 dy by dx's. So this leaves me with just dy by dx on the left hand side. And we have 3 plus 2 plus 2, which is equal to 7. Great. Okay, question 7. We have a beautiful, pretty little picture. We have 2 parametric equations, and it says that the region inside the first quadrant is bounded by C and the coordinate axis, and it's perfectly symmetrical. Show that the area of the shaded region is given by the integral of this. Okay, we can do that. First off, let's look at the limits. So we need to investigate this point here. That's going to be our upper limit. And that happens when y equals 0. So when y equals 0, that means that 12 sine theta equals 0, which means that sine theta equals 0, which means that theta is equal to 0 or pi or 2 pi, but not 2 pi because theta cannot be exactly 2 pi. So these are the 2 times, then it can equal 0. Now which is the one that we want? We want the one which has a positive x coordinate, because right there the x coordinate is positive. So if I sub 0 into here, I get positive 1, which is great. If I were to sub pi into there, I would get negative 1, which is not great. So 0 is my upper limit. Okay, let's look at the lower limit, and that is going to be at this point here. And that point there is when the x coordinate is equal to 0. So that's equal to cos cubed theta, which means that cos theta equals 0, which means that theta is equal to pi over 2 or 3 pi over 2. Those are the times when cos theta equals 0. And again, we want the y coordinate there to be positive. So let's sub in here. Sine of pi over 2 is 1, so that's going to give me 12, so that is going to be positive, so that's good. If I were to sub this in, sine of 3 pi over 2 is negative 1, so negative 12, so that's not the one we need to use. So these are our 2 limits, with the green one being the upper and the yellow, the purple one being the lower. Okay, so what is our formula? Our formula is, for parametric equation, we integrate y times by dx by d theta between b and a. So what do we know so far? We know that the upper limit was 0 and the lower limit was pi over 2. Y we know is 12 sine theta. We also know that x is equal to cos cubed, so I'll write it like this. So if I want to differentiate that with respect to theta, then I'll bring the 3 down to the front, I'll keep the bracket the same, I'll drop the power down by 1, and then I'll times by the derivative of the bracket, and the derivative of cos is minus sine, so I'll times it by minus sine, and I'll put a little minus sign here. Okay, so that needs to go in here, which gives me minus 3 cos squared theta sine theta. Okay, and we've got a 3 and a 12, so that makes 36. That can go outside. We've got a cos squared. We've got a sine times sine is a sine squared. And we've got a minus, which is a bit annoying, because there's not a minus in here. But we can get rid of the minus by flipping the signs over, the limits over, sorry. So when I flip the limits over, I'm essentially multiplying the integral by -1. So that's going to get rid of my negative sign there. Okay, great. So that is part A done. And now we need to use trig identities to show that cos squared sine squared is equivalent to 1/8 1 minus 4 cos theta. Okay, let's do that over here. And I'm going to use cos 2 theta is the same as 2 cos squared theta minus 1. And I'm going to rearrange that for cos squared. So that's going to give me cos 2 theta plus 1 over 2 is equal to cos squared theta. And I'm also going to use that cos 2 theta is equal to 1 minus 2 sine squared theta. So rearranging this, I will get 1 minus 2 theta, 1 minus cos 2 theta over 2 is equal to sine squared. Okay, that's going to be really helpful because, of course, we've got a cos squared and a sine squared here. Okay, I'm going to substitute in into this identity. So cos squared I'm going to replace with 1/2 cos 2 theta plus 1. And sine squared I'm going to replace with 1/2 1 minus cos 2 theta, like so. So this is the same as 1/4, and what you'll notice with these two brackets is this will give us a difference of 2 squares. So that's the same as 1 minus, or 1 squared minus 2 cos squared 2 theta, like so. Okay, and we want this to be equivalent to 1/8 1 minus cos 4 theta. So what I might do over here is just write out what cos 4 theta is equal to. Now, we know that using the double angle formula, this is equal to cos of 2 theta plus 2 theta. And we know the double angle for cos is 2 lots of cos squared, in this case now will be 2 theta minus 1. Okay, so what I can do is I can rearrange for cos squared 2 theta, which is what I have over here. So this will give me cos to the 4 plus 1 divided by 2 is equal to cos squared 2 theta. And now I can replace that over here. So I will get 1/4 1 minus 1/2 of cos 4 theta plus 1. And then we can expand out, so this gives me 1 minus 1/2 cos 4 theta minus 1/2. and this will give me 1/4 a half minus a half cos 4 theta, which gives me my 1/8 1 minus cos 4 theta as required. Okay, great. Let's go up to here. It then asks me to find in terms of pi the total area enclosed by C. Well, the total area is going to be 4 times the shaded region because of the symmetry. So I need to do 4 times this integral here, and I'm replacing this cos squared sine squared with 1/8 1 minus cos to the 4. Okay. So I will need to do 4 times 36, the integral between pi over 2 and 0 of 1/8 1 minus cos 4 theta d theta. Okay, let's take the 8th out. So that will give me 18 pi over 2 between 0, 1 minus cos 4 theta d theta. I will then integrate. 1 integrates to theta, and cos 4 theta will be 1/4 sine 4 theta. Okay, when I sub in pi over 2, I will get, first off, pi over 2 goes into for theta, and pi over 2 times 4 is 2 pi, and sine of 2 pi is 0, so that's that bracket done. Then subbing in 0, I'm going to get 0 minus, and sine of 0 is 0, so that gives me 0. So overall I get 18 pi over 2, which is just 9 pi. Okay, question 8 is a graph transformation question, and it says that it has been translated by the vector 3, 1. So 3 means that I will need to do f of x minus 3. That's a shift in the right by 3. And 1 means it shifts up by 1, which means I'll need to add 1 to the function. So this is what I will need to calculate. So I get 1 is equal to y is equal to 1 over the x cubed. Well, I need to replace the x's with x minus 3 squared plus 1 on the denominator, and then I need to add 1 to the function. And that's good. That's good for part A. I don't need to simplify it. It doesn't ask me to simplify it, so that's part A done. Part B, it says describe fully a sequence of 2 transformations which map the graph of C onto the graph of, with the equation y equals 1 over x cubed minus 1. Okay, so this is quite tricky, this. Adding or subtracting something to this function is not going to help. Also, stretching it won't help. I think this is going to be a reflection. So I'm going to start by looking at what would f of minus x look like. If I replace the x with a minus x, then this would give me y is equal to 1 over minus x cubed is minus x cubed plus 1, which is similar to this. It's just it's the negative of it. So the next graph transformation I could do is minus f of minus x, and what this will do is this will just multiply the function by negative 1, which is the same as multiplying either the denominator or the numerator by negative 1. Let's multiply the denominator by negative 1, and that will give me x cubed minus 1, which means I've now arrived at the function they've asked me to. So what are these two transformations? It's asked me to describe them. Well, the first one was a reflection in the y-axis, and the second one is a reflection in the x-axis. Okay, we're asked to put it into completed the square form, so I can write f of x is equal to 3 lots of open brackets x squared minus 6x close brackets plus 21. If I complete the square inside the square brackets, I need to half the b term, which will give me minus 3. So x minus 3 all squared, and then I take away minus 3 squared, which is 9, so I take away 9. Plus 21. I multiply out the bracket by 3, and the minus 9 by 3. So I get 3x minus 3 squared minus 6. And that's part A. Part B asks me to find a simplified version of the inverse function. Well, to do that, we set the function equal to y, and then we essentially reflect it in the line y equals x, which means we swap over the y's and the x's, and then we rearrange to make y the subject again. So I get x plus 6 and then divided by 3 is equal to y minus 3 squared. I then square root both sides. So x plus 6 over 3 is equal to y minus 3, and when I square root I get a plus or minus. And then I add 3 to both sides, and I will then write it not as y is equal to, but as the inverse function is equal to. So I'm going to get positive 3 on that side, and I'm going to get plus minus the square root of x plus 6 over 3. And then when we do the inverse of a quadratic, we've got to then look at the domain of the original function. So the domain of the original function is that x is greater than 4. Okay, so let's draw a little diagram here, because we're going to be looking at domains and ranges. And we start off with this domain here, that x is greater than 4. And then that allows us to pass through a function of f. And if we want to go the other way, we'll need to use the inverse function of f. So what this tells us is that the domain of f is the same as the range of f to the minus 1. So my domain of f is x is greater than 4, and that has to be the same as the range of the inverse function. So the inverse function is only allowed to spit out values which are greater than 4, so therefore I cannot have a minus sign here, because that will give me a value which is less than 4. So I have to disregard the minus sign and allow this to be our inverse function. It then says calculate the domain and the range. Well, we've done that already really. The range of f to the minus 1 is that f to the minus 1 of x has to be greater than 4. And now the domain is going to be whatever's inside this bracket, inside this box here. And the domain of the inverse function is the same as the range of the original function. Okay, how can we work out the range of a quadratic? Well, we could plot it. And I can type it into my calculator like this. I can click draw. I can then go to V window, and I want the x minimum to be 4 because we know the domain is greater than 4. So it looks like this. So it's just an increasing function. So we just need to know what the low point is, and the range will just be anything greater than that. We could do that by going gsolve. We can solve for the y coordinate by subbing in the x coordinate is equal to 4. And it tells us it's -3. So great, that means that the range of f is that f of x is greater than -3. So therefore the domain of the inverse function is that x is greater than -3. Question 10, we've got a lovely looking trigonometric graph. We've got the function, and it says use differentiation to show that the range of f of x is between these two values here. So we need to work out what the top or the maximum value is and what the minimum value is, and the range will be in between the two. So that's why we're going to use differentiation. We're going to differentiate this, and we're going to use the quotient rule. So we get the u is equal to cos x, and the v is equal to 3 minus sine x. Differentiate these. The derivative of cos is minus sine, and the derivative of minus sine is minus cos. So the overall derivative is going to be v times by du, which is minus sine, so I'll put the minus outside there like that. And then we're going to take away u, which is cos x, times by the derivative of v, which is minus cos x. And that is all over 3 minus sine x all squared. Okay, let's expand out this bracket. We will get minus 3 times sine x, so that's just minus 3 sine x. We'll get minus sine x times sine x, so that's just plus sine squared x. And we'll get minus cos x times a minus cos x, which is plus cos x squared. And that's all over it again. I don't want to expand this one because it's on the denominator. Okay, we know that sine squared plus cos squared is equal to 1. So we have 1 minus 3 sine x all over 3 minus sine x all squared is equal to the derivative. And when do my maximum minimums occur? They occur when the derivative is equal to 0, and I have a fraction here, so I'm only concerned about the numerator equaling 0 in order to make the fraction equal 0. So I can write that 0 is equal to 0 is equal to 1 minus 3x. So that tells me that sine x is equal to 1 over 3. Okay, great. But what I need is the y coordinates, because I need to know how high up these turning points are. And I find the y coordinates by subbing into the y formula. Now I know sine x, but I'm also going to need to know what cos x is in order so I can sub into here. And I'm going to want them in exact form, so I don't really want to solve for x by using sine to the minus 1. Instead, what we're going to do is we're going to use our identities. So I know that sine squared x is equal to 1 over 9. And I know that this is equal to 1 minus cos squared x. So I know that cos squared x is therefore equal to 8 over 9, which gives me that cos x is equal to minus 2, or sorry, plus or minus 2 root 2 over 3. Okay, great. Now let's substitute into the function to get these y coordinates, which are the maximum and minimums. Okay. So cos, we know, is plus or minus 2 root 2 over 3. And well, that is all over, this is going to give us our y values, 3 minus sine, and sine was 1/3. Okay, great. Let's multiply through by 3, top and bottom, to get plus or minus 2 root 2 over 9 minus 1, which is obviously 8. Okay, so this simplifies down to plus or minus root 2 over 4. Okay, fantastic. And I think that is fine. We know, shown that these points here, the maximum and minimums, we know what the y values are, so obviously the range is in between them, as you can tell from the graph. So therefore we can write that minus root 2 over 4 is less than or equal to f of x, which is less than or equal to root 2 over 4. Bosh. Question 11, we've got, looks like a differential equation. We've got a water leaking out of the hole of the bottom of a tank. Let the height of the water be y at t minutes. Given that the time after it started leaking, the height of the water is decreasing at a rate proportional to the cube root of the height. Okay, so let's put that into mathematical context. So the height of the water in the tank is decreasing at a rate. So decreasing rate means that the height dy by dt, because it's respect to time, is going to be proportional to, it's decreasing, so negative, and we have the cube root of the height. So that is y to the power of a third. Okay, so that means we can rewrite this as dy by dt is equal to minus k, so some constant, multiplied by y to the power of a third. And then we can multiply through by dt and divide through by y to the third, like this. And then finally we can write this as y to the minus third dy is equal to minus k dt, and then we can integrate both sides. Okay, what do we get when we integrate? Well, the power goes up by 1, so 2/3, and then we divide by the new power, so times this by 3 over 2. And this will equal minus k will integrate to minus kt with respect to t, and that'll be plus c, some other constant. Okay, we've got two arbitrary constants, k and c, so we're going to need two sets of information, set 1 and set 2. Let's start by subbing in set 1. When t is equal to 0, y is equal to 125. So I'll go to my calculator and I will do 3 over 2 multiplied by 125 to the power of 2/3, and this will give me 75 over 2. And t is 0, so kt will be 0, and we're just left with c. So that tells us what c is. Great. Now we use the other bit of information, and that is when y is 64. So going to my calculator and changing y to 64 is going to give me 24. And t is free, so I'm going to get minus 3k and plus c, which we know is 75 over 2. Great, so I do 24 and I minus 75 over 2, and then I divide by minus 3, and I get 9 over 2. So k is equal to 9 over 2. Okay, so what I can do is I can replace k and c in this formula up here, and this will give me minus 9 over 2 t plus 75 over 2, and I can multiply both sides through by 2, which could be helpful, so I get 3y 2 over 3 as the power is equal to minus 9t plus 75. Okay, so this is my final solution, and I can use that now to find y by subbing in t is equal to this, and that incidentally is the same as 91 over 12, which might be easier. Okay, so subbing in, I will get I'll get minus 9 times 91 over 12 plus 75 gives me 27 over 4. I think we might be able to do the rest without a calculator. So that gives me 27 over 4. Divide through by 3 gives me 9 over 4. And then if I want to swap the power over to the other side, I will just take the reciprocal of the power, so that will be 3 over 2. It's a nice neat trick, which means I'll need to square root and then cube. So square rooting gives me 3 over 2, cubing gives me 27 over 8. Brilliant. Question 12, we need to fill out the missing values for y. So we're going to do that on our calculator, and we're going to do just fraction 0.3 squared over 2 times 0.3 plus 1. Okay, let's use a fraction, so 9 over 160, and then let's do the same for 0.4. Change that to 0.4. And we get 4 over 45. Great. Easy marks. And then it says use the trapezium rule to work this out. Okay, I'm just going to do this all on my calculator. So the trapezium rule states that you need to take the height, which is the distance between each of the x values. So that is 0.1, and we need to divide that by 2. We then need to multiply that by the two endpoints, which are 0 and 1/8 added together, plus all of the ones in the middle need to be multiplied by 2, and those need to be added together as well. So you would, in your exam, obviously write what you're doing down to get the method marks. I'm being a bit lazy and just using my calculator to do the whole thing. And it says to 4 significant figures, so that is 0.02445. Bosh. Okay, and now we need to just do this integral without using the trapezium rule, using substitution. So I'm told that u is equal to 2x plus 1. So differentiate this gives me du by dx is equal to 2, which means that dx is equal to du over 2. Okay, I'm also going to rearrange this to make x the subject. So that's going to be u minus 1 is equal to 2x. So u minus 1 over 2 is equal to x. So squaring that is going to give me u minus 1 squared over 4 is equal to x squared. I'm also going to need to do my limits. So I know that x, at the moment, we have a limit of 1/2 and 0. So what would that be for u? Well, u is 2 times the x plus 1. So 2 times 1/2 is 1 plus 1 is 2. And 2 times 0 plus 1 is 1. Okay, I think I'm good to go now. I've got everything set up, so I can just do my replacing. So 1/2 gets replaced with 2. And we have 0 replaced with 1. We have x squared on top. So what I'll do is I'll take a quarter out and I'll just put u minus 1 squared on top. And on bottom we have 2x plus 1, which is just u. And that is, and dx also needs to be replaced. And that is du over 2, so I'll just put du there and I'll take a 1/2 out, so I'll change that to 1/8. Okay, great. Now, an integral like this, it's not pretty. You just need to expand the top and then divide through by u. So, whoops. Right, so that's going to be 2, 1. We're going to get u squared minus 2u plus 1 over u. So that's going to be the same as u, because u squared divided by u is u, minus 2, and then plus 1 over u. Okay, great. Right, moving up here. This is going to give us, when I integrate, 1/2 u squared minus 2u plus ln u between 2 and 1. Okay, what is this going to give us then? So subbing in 2 is going to give me 4 over 2, which is 2, minus 2 times 2 is 4, plus ln 2. And then minus, when I sub in 1, I'm going to get 1/2 minus 2 plus ln 1, which is 0, so I can close off the bracket there. Okay, fantastic. So that is 1/8 minus 1/2 plus ln 2. So when I take an 1/8 there, I'm going to get 1/8 ln 2 minus 1/16. And I think it asked me to find an exact simplified value for that. Okay, I've done that. Hence, deduce by referring to parts B and C the approximate value of ln 2 to correct to 2 significant figures. Okay, so this is the exact value for the integral, and we also have this as a approximate value for the integral. So we can set these equal to each other. 0.02445. So on my calculator I can take 0.02445 and I can add on a 16th, and then I can times it by 8, and that will give me 0.6956. Okay, and it asks us to give it to 2 significant figures, so that's approximately equal to 0.70. And we're done. Okay, final question. We have a a trigonometric equation, nice and simple. And the first thing I've spotted here straight away is that we've got an even power minus an even power, so we can use difference of two squares. So taking the square root of each one and then adding them together, and then multiplying them by them minus to one another. And that's going to be equal to 2/3 plus root 3 cot theta. Okay, and we have an identity which connects cot and cosec. If you don't know it off by heart, then never fear, because you can always just go with the cos squared plus sine squared equals 1. I want to get a cosec, which is 1 over sine squared, so just divide through by sine squared, like this. And this tells you that it's going to be like that, is it? So this tells us that 1 plus cot squared theta, because that's cos squared over sine squared, is equal to cosec squared. So it's an easy way of remembering if you've forgotten. Okay, so we can rearrange this. This is going to be nice and helpful. For cosec squared theta minus cot squared theta is equal to 1. So this now becomes cosec squared theta plus cot squared theta times by this, which is equal to 1, is equal to this, and cosec squared plus cot squared, well, I've got a cot on this side, so ideally I want my whole equation in terms of cot, so I want to remove cosec squared, and we know that cosec squared is 1 plus cot squared, so add another cot squared, we get 1 plus 2 cot squared is equal to 2/3 plus root 3 cot theta. This is a quadratic, so let's simplify this by writing it all on one side. So it's all to the left side, so minus root 3 cot theta, and then minus the 2/3 from the 1 gives me just 1/3 equals 0. Multiply through by 3 and replace the cot with a y is going to give me 6y squared minus 3 root 3 y plus 1 equals 0. Okay, now this is a quadratic we can solve, so I can just go to my calculator, because I'm lazy, and go to equation, go to solver, polynomial, sorry, degree 2, and we've got 6y squared minus 3 root 3 and plus 1. And we get 3 root 3 and, so root 3 over 3 and root 3 over 6. Okay, so these are all y equals, so they're all cot equals. So cot theta is equal to root 3 over 3. And we also have that cot theta is equal to root 3 over 6. And cot is the reciprocal of tan. So if I want to convert between cot and tan, I just flip. So I'm just going to flip over like this. And now I'm going to find the values of tan. So I'm going to go to shift tan of 3 over root 3. Fantastic. This gives me pi over 3. And to find the second solution for tan, I would just add on pi. So this gives me 4 pi over 3. Just check the range is between 0 and 2 pi. Fantastic. So that's all that I'm going to get out of that one. And this one here, I'm going to go back to my calculator and I'm going to change that to a 6 on top. Okay, that does not look exact, but I think that's fine. We will just use the decimal there of 1.29. Does it say give it to a degree of accuracy? No, it doesn't. Okay, fine. And then I'll add pi to that to get my second solution. So I'll add pi, and that will give me 4.43. And we're done. Thanks very much for watching. I hope that was useful. If it is, please do subscribe to my channel. That'd be greatly appreciated. And I've got more A-level content that way. Bye for now.